Hey, amazing fourth graders. Today's math lesson is going to be a little bit of review from yesterday just to make sure we understand it. And then we're going to add on to that again. So we're going to talk about fractions greater than a whole and a mixed number. So going back to fractions, fractional means a part of a whole. We have numerator, the top number, denominator, the bottom number. My fraction is 2/3. Bottom denominator tells me 3 pieces in the whole. Top numerator tells me I'm referencing 2 of those. So there's 1, 2. 2/3, 2/3. So now I'm going to add to that 2/3 plus another 2/3. So I know when I'm adding fractions, if it has a common or the same denominator, the same size pieces, and they both have thirds, all I have to do is add the numerators together. So I have 2 pieces plus 2 more pieces, so my numerator is 4. So I have 4/3. And when I'm talking about fractions, here's my fraction bar that has one whole piece, and it needs 1, 2, 3 pieces to make a whole. There are 3 pieces, so my denominator is 3, and how many would fill in that whole? 3. So 3/3 equals 1 whole. All right, so I have 2/3, 1, 2, and I'm adding 2 more thirds. Here's 1 more, and I'm going to have to make a new fraction bar because I have 1 more third to add to it, and 3. So I have 2/3 plus 2/3 equals 4/3. 1, 2, 3, 4/3. When my top numerator, the top number is bigger than the denominator, that's a fraction greater than a whole. Because look at 3/3. When my top numerator, bottom denominator are the same, it means I have the whole thing. I have more than a whole. So I have 1 whole, and then I have 1 extra piece, and that piece is a third. So 4/3 is 1 whole and 1/3. This is a fraction greater than a whole. This is called a mixed number because it has wholes and fractional pieces. 1 whole, and there's my fractional piece. We're going to try one more of those. My bottom denominator is 5, so I'm going to make a fraction bar. How many pieces are going into that to make a whole? 5. So here's my fraction bar that has 5 pieces. Remember with fractions, fractions are equal. I'm trying to get equal pieces, so 5, and I'm going to reference 4 of those. So here's 1, 2, 3, 4/5, and I'm going to add to that 3/5. I have a common or the same denominator, so my size pieces are going to be the same. Here's my 4, I'm going to add 3 more. Here's 1, oops, I filled up that whole fraction bar, so I've got to make another one. And I need to add 2 more onto that. So now my pieces are 5ths, because there's 5 in that whole, and there's 5 in that piece. And I added 4 plus 3 more. My bottom denominator, my size pieces are 5ths. My numerator, the pieces I'm referencing are the 4 plus the 3 more. So that's 5, 6, 7. 7/5. And what did we learn? When the top numerator is bigger than the bottom denominator, because this tells me I need 5 pieces to make a whole. I've already got those 5. Here they are here. So I have 1 whole, and I have 2 pieces left, and they're 5ths. So 7/5 equals 1 2/5. Fraction greater than a whole, mixed number. And if I don't want to draw the fraction bars, because pretty soon the more we do something, like I said, the easier it gets, I can look at 7/5 and I know in my head I only need 5 pieces to make a whole. So I could say, oh, I'm going to take the 5 away from that 7 to make 1 whole, and I have 2 left after I subtract 5 from 7. 2/5. 1 2/5. Mixed number, fraction greater than a whole. I'm going to talk about the fraction 1/2. We're all familiar with 1/2. I always say, oh, I'll give you half of this. I'll give you half of that. So we've been familiar with 1/2 since we were little. So I'm going to turn 1/2 to as my denominator, my size pieces, and I'm going to turn it into a fraction greater than a whole, 5/2. That means I only need 2 pieces to make a whole, and I have 5 of them. So if I were to make my pies, 1, 2, 3, 4, 5, I would have 1 plus 1 plus 1/2. 5/2 equals 2 wholes and 1/2. Fraction greater than a whole, mixed number. So I could also do this repeated subtraction, and you know where I'm going with this because we know repeated subtraction is the same thing as division. You're right. So I'm going to take my 5/2, fraction greater than a whole, mixed number, and I'm going to subtract 2/2, I know that's 1, minus 2/2 minus 1/2, because 2, 3, 4, 5, 5/2. So that's minus 1, minus 1, minus 1/2. That's 2.5. Repeated subtraction, division. How would I take 5/2 and make that a mixed number by division? 5 divided by 2 equals, how many 2's are in 5? 2, 4, 6, oh, too many, 2, 4, 2, and it's remainder 1, that piece is 1/2. 5 divided by 2 is, well, let's do it this way, 2, remainder 1, and what size are those? Halves. So it would be 2 and 1/2. Still a little confused. Let's try another one. I know my 5s. This is why it's important to know your math facts, to know your multiples. We all can do 5, 10, 15, 20, 25, 30. So I'm going to use 5 as my denominator, which means my size pieces are 5. So to make 1 whole, it's going to take 5 pieces. So 5/5 is 1 whole. But I'm going to put 21 pieces. This is a fraction greater than a whole. So I only need 5 pieces to make a whole. So how many of those can I make? I'm going to do 21 divided by 5. That means how many 5's are in 21? Because I need 5 pieces to make a whole. 5, 10, 15, 20. There's 4 of them left. 4, remainder 1. 4, remainder 1. So if I were to do 21/5, if I were to draw it as a fraction bar, I would have 1, 5, 10, 15, 20, 21. So I have 1 whole fraction bar, 2 whole fraction bars, 3 whole fraction bars, 4 whole fraction bars. That's 4 whole fraction bars and 1 piece left. And what is that? A fifth. 4 and 1/5, mixed number. 4 and 1/5, 4 remainder 1. Math is patterns. Let's try 2 more. Fourteen thirds. 14 thirds is a fraction greater than a whole because I know I only need 3 pieces to make that whole, but I have 14. So how many of those wholes that take up 3 pieces can I make out of the 14? I could do fraction bars, I could do repeated subtraction, but I know repeated subtraction is division. 14 divided by 3 equals, here's where those multiples come in, 3, 6, 9, 12, 15's too much, so it's 3, 6, 9, 12. It's 4, remainder 2. 4, remainder 2. That means I have 4 wholes, 2 left, and they're thirds. Mixed number. 4 remainder 2, 4 wholes. The 2 pieces that remain are thirds. How about 7 halves? I'm going back to my halves again because I want you to understand the concept of this. Fraction greater than a whole. My denominator is 2. That means I only need 2 pieces to make 1 whole. I have 7 of those. So how many of those wholes will I get? 7 halves, which is a fraction greater than a whole, equals 7 divided by 2. How many 2's are in 7? 2, 4, 6. 3 of them with 1 remainder. 7 halves equals 3 wholes, my 1 remainder, and what size? Halves. 7 halves equals 3 and 1/2. Fraction greater than a whole, mixed number. (15/4), fraction greater than a whole. How many pieces do I need to make a whole? My denominator tells me 4. So how many 4's are in 15? That's division. 15 divided by 4 equals 4, 8, 12, 16's too many. 4, 8, 12, so that's 3, remainder 3. 15/4 equals 3 wholes, remainder 3, and the pieces are fourths. And here's something interesting. You know how addition and subtraction are related because they're inverse, they're opposites, and we can always check our math? And then when we do division, we can do the inverse, which is multiplication, and check it that way. We're going to do some switching back and forth with fractions. We're going to switch back and forth from a fraction greater than a whole, which is 7/3, and how I would switch that into a mixed number would be how many 3's in 7, I know there's 2 and 1 left, 2 1/3. Okay, so here comes the pattern. I'm going to do 2 1/3. I'm going to switch that back to a fraction greater than a whole. 2 1/3, I'm just going to turn it all back into thirds. I know 2 is 3/3, which is 1 whole, plus 3/3, which is another whole, plus 1/3. So now my bottom denominator tells me those pieces are 3, and I have 3, 6, 7 thirds. Interesting. There's a relationship going on there. Six fourths, fraction greater than a whole, becomes a mixed number because I know 6 divided by 4 is 1, remainder 2. The size pieces are fourths. If I work that back together in the opposite way, 1 2/4 equals, I'm just going to turn it into fourths, as in a fraction greater than a whole. Since I'm talking about fourths with my denominator, 1 whole is how many fourths? 4. 4 fourths plus 2 fourths equals 6 fourths. 6 fourths and 6 fourths. Pretty cool how that works. Mixed number, 3 wholes and 2 fifths. I'm going to change that into an improper fraction, or I'm sorry, a fraction greater than a whole. My bottom denominator is 5 because my pieces are fifths. So I'm going to take 3 wholes, and I know since my denominator is 5, I need 5 pieces for a whole. So I'm going to go 5 fifths plus 5 fifths plus 5 fifths because that's 1 whole, 2 wholes, 3 wholes plus 2 fifths. 5, 10, 15, 16, 17. 17 fifths. 17 fifths. Is that right? Let's check it. 17 divided by 5 is 3, remainder 2. 3, there's my remainder, in 2 fifths. I'm starting to see another way I could do this, but we'll try one more, and then we'll see if anybody else finds out what I just noticed. Because remember patterns. 4 3/4. This is a mixed number. I'm going to turn it into a fraction greater than a whole, just with fourths. So if my bottom denominator is 4, in order to make a whole, I have to have the numerator the same. So 4 of those would be 4 fourths plus 4 fourths plus 4 fourths plus 4 fourths, plus my 3 fourths. Watch this. 4, 8, 12, 16. That was almost like 4 times 4. Remember that. 16, 17, 18, 19 fourths. 4 wholes is 4 fourths plus 4 fourths plus 4 fourths plus 4 fourths. Repeated addition is multiplication. Oh, 4 times 4 are 16 plus 3 are 19. Because this is 4 times 4. 4 times 4 is 16 plus 3, 19 fourths. Fourteen thirds. I'm backtracking. This is a fraction greater than a whole. How do we turn it into a mixed number? How many 3's are in 14 so I can make all those wholes? 14 divided by 3 equals 3, 6, 9, 12. 4, 2 remain, 2 thirds. Mixed number. If I were to take that 4 and 2 thirds and turn it back into a fraction greater than a whole, 4 times 3 are 12 plus 2, 14. What size pieces? Thirds. Wow. How did that work? Because my pieces are thirds, so it's 3 thirds plus 3 thirds plus 3 thirds plus 3 thirds. That's 1 whole, 2 whole, 3 whole, 4 wholes. There's my 4 as a whole number plus my 2 thirds. 3 times 4, or 4 groups of 3, 4 times 3. This is 4 groups of 3 plus 2 is 14, and they're thirds. 4 times 3 is 12 plus 2, 14 thirds. Mixed number. Denominator is 5, my pieces are fifths. I'm going to turn 7 fifths into a fraction greater than a whole. And I know to make one whole, when my bottom denominator is 5, my top denominator is 5. 5 fifths is one whole, but I want 7 of those. So that would be 7 groups of 5 fifths, or 35 fifths plus 1 fifth equals 36 fifths. 7 times 5 is 35, plus my 1 is 36 fifths. Three and 2 thirds, mixed number. I'm going to make it a fraction greater than a whole. Bottom denominator is 3, so that means I need 3 pieces to make a whole. And I have 3 wholes, so that would be 3 thirds plus 3 thirds plus 3 thirds, or 3 times 3 is 9 plus 2. 11 thirds. 6 and 2 fifths. 5 is my bottom denominator. My size pieces are fifths. I need 5 fifths to make a whole, but I have 6 of those. I have 6 groups of 5 fifths. So how many of those fifths do I have? 6 times 5 are 30 fifths, plus my 2 fifths, plus 2 fifths, 32 fifths. This is a new concept. I want you to really take your time and look at it, and maybe watch this video another time and stop it, try it yourself. And then if you still need help, please email me, let me know, and I will do a Zoom with the class. So we have mixed number, fraction greater than a whole. They're related, they're the same number.